It's been over 2 months since the last proper video, but I've been really busy. I designed a CNC router, I've been working on Nephele's Pelvis. In this video we're going to talk about the gearbox for Nephele's Pelvis. I'm going to give you a preview of what's to come with the router. Thank you so much for tuning in. I'm Josh Whitman, CEO of Whitman Technological. Let me start by talking about the FerrousCNC. It's an all-steel CNC router. I wanted something a lot more rigid than the flimsy wooden one that I built down in the basement. So I designed and am in the process of building an all-steel version of that should be extremely rigid, more than capable of milling and routing various types of materials. Some of the parts need to be welded together, and I wanted to make sure that my welder was still in good working order. So I broke that out, took some of the test parts that my dad sent me, and attempted to weld, figured out what was going wrong with my welder. It turns out that some of the wire inside the cord was corroding, and I was able to pull that wire back out, and then everything worked very well. In this video, I'm going to show you the first version of it. I actually started over from scratch after 13 hours in CAD, because I took what I had after 13 hours and I posted it on Reddit, and I said, hey, check out what I made. It's like 13 hours into the design, and people came back with some feedback of like, it seems like there's a lot of torque going on. I took that to heart, and it was obvious I should just kind of adjust the design, and it was easier to just start over from scratch and rebuild it all up than go back and modify all the little pieces. So the version you're going to see in this video is the first iteration, up to the point where people said you could probably do that a little differently and get better results.
Little bit crazy, little bit racy, little bit tame, what am I saying? I wanna let go, gotta get out, feels like I'm caged in. I know something is awakening, it's in my soul. For something, no more, my heart's drumming. I wanna let go, breathing this air intoxicating. Don't care, I'm not waiting. It's in my soul. Feels so right now, waiting till the sun's down, waiting till the sun's down. Just can't stop now, waiting till the sun's down, waiting till the sun's down.
I took a crack at using a Hall sensor for position detection using the detection of magnetic fields, and I was really excited about that. It turns out that's really, really easy. Let's do a little time lapse of the coding for the Arduino to read from a Hall sensor and send that data to through the serial port. And that's literally it. It's like 5 lines of code. It's so cool. It's just just awesome how easy and painless this is. And if we go and we move a magnet around in front of the sensor, then we can easily see that it's very accurately, very repeatably and reliably detecting the magnetic field at the sensor. I read a little bit about nylon as a printing material, and I looked into some videos where people were doing nylon, and holy smokes, it is super cool. It is also very difficult to print. The parts I printed are really tough. They're unbreakable. There's amazing layer adhesion. There's like no wear. The nylon will just flex rather than abrade. I tried filing it. I couldn't file it. The only way to remove like hairs and stuff from the print was to shear them off with a razor blade. But you have to print a little hotter. The pressures are a little weirder because it's more like printing a rubber band than printing something solid. At one point, the hot end for my printer was completely encapsulated in just a solid ball of nylon. And I had to use a hacksaw to cut the nylon off piece by piece until eventually I could get the hot end out and get everything taken apart. And then I had to burn the nylon out of the hot end with a torch, put it all back together. I got a couple more prints out of it, or at least attempted prints out of it. Nylon also extremely hygroscopic, so just in the 2 or 3 days that the printer was down the first time, it absorbed so much moisture that it was unprintable when I finally got my printer working again. And then I went and bought a toaster oven and I baked the nylon for 6 hours, and then it was mostly printable again, but the printer broke after just 2 or 3 more print attempts. I also discovered it doesn't adhere to PEI sheets. I had read that PEI was a good printing base for printing nylon. That was not true. I had to flip the glass over so the PEI was face down and then use hairspray. I was able to get maybe 4 or 5 workable parts. My printer broke twice. And then I almost cut my knuckle off of my finger. And that's when I was like, okay, too much with the nylon. This material is just a little over my head right now. I want to keep making progress on the gears and the pelvis. So I'm going to just print it in ABS. You know, it turns out nylon's fantastic. So I'm going to look at that more seriously in the immediate future once my printer is upgraded to the point where it's up to the challenge of printing nylon. So one of the big discoveries I made just now, in addition to the Hall sensors, which are awesome, is the Gears Workbench for FreeCAD. At first I didn't want to use it because I didn't like the tooth profile of the bevel helical gear that it was producing. The teeth just looked a little too trapezoidal and like they were missing the involute detail that I was expecting. So I didn't use it at first, and I posted a video of making these planetary gears on Reddit, and somebody was like, hey, we checked out the Gears Workbench. And I said, yeah, but I didn't really like it. I stuck with the involute gears because I knew what I was doing there. But later I went back and looked at it again because I had read some stuff that showed how you could adjust like the gap between the teeth. You can add backlash, you can increase or decrease the amount of space into the tooth or at the tip of the tooth sticking out. And all those adjustments allowed me to accommodate the fact that my printer is going to go about 1/10 of a millimeter past whatever the boundary is set for. So that means normally when I print teeth, they will never properly mesh. They will always be just kind of the tips will be butting up against each other. And that's as much engagement as I could hope for. But now with the FC Gears Workbench, I'm able to reduce the size of the teeth so that when they print to exactly the size they're supposed to be. And that means I can have full tooth engagement in my 3D printed parts. And Nephele's pelvis is it's going to be a set of bevel gears that, as the central bevel gear rotates, it causes essentially the linkage that goes from the pelvis out to the hip to raise and lower on both sides opposite each other, which is that's essentially what we want, is just the ability for the legs to move apart and together and to actually cross over past each other. I kind of imagine like somebody roller skating and how their back leg would be up in the air and move behind them. Because Nephele is on wheels, Nephele is going to operate a lot like a roller skater would. And so I wanted the ability for a whole range of balancing to happen using the legs as counterweights. I missed you guys, man. It was a long time between videos, and I was just held up with the router project. I finally switched gears onto the Pelvis while I was waiting for some things to be done, and then I was having so much trouble with this nylon that a couple weeks went by, and it's like, oh, it's been 2 months now. So thank you so much for watching. I'm Josh Whitman with Whitman Technological. I love science, and I hope you do too. I'm Josh Whitman with Whitman Tech. Cheap, easy, fun, powerful, rigid. Anyway, okay. Essentially kick like a Kung Fu Ninja or whatever. There's no Kung Fu Ninja. I don't want to be somewhere crazy.